This is the laboratory exercise number 6 entitled Creating Sounds and Tones with Piezo Speaker. For the first step, I am currently reading and reviewing all the important information needed for this laboratory exercise, including its overview, required materials, procedures, guide questions, and the sample circuit design, which I will later create on my own. And this is the code provided already in the laboratory manual, including also the post-lab questions and the references. It is very important for any academic paper to be supported by reliable and credible sources. To gather the necessary information for this laboratory exercise, I conducted research on topics related to the experiment, including its definition, common terms, components, functions, application in daily life and engineering, and its overall significance. The first source provides essential background information and concepts that are relevant to this laboratory exercise. It helped me gain a better understanding of the topic and its practical applications. Another source contains detailed information about the piezo component, including its functions, operating principles, and various applications. It is relevant to the subject of basic electronics as it explains how piezo devices are utilized in electronic circuits and systems. For the circuit design for laboratory exercise number 6, the materials needed are the following. First, we need to have a 1 Arduino Uno R3, 1 USB cable, 1 piezo speaker which is called a buzzer, and 1 breadboard, a connecting wires, computer with Arduino software. At this moment, I am now creating my own circuit design using Tinkercad, and now I am searching the components using the basic components available only in Tinkercad, in which I have now my piezo speaker, my breadboard, and my Arduino Uno R3. In my case, for this laboratory exercise 6, I still used alternative software to complete the activity in Tinkercad instead of using actual hardware. I gathered the needed components such as an Arduino Uno R3, piezo speaker, breadboard, connecting wires, USB cable, and a computer with Arduino software, just like what I mentioned earlier. In the simulation, I connected the positive pin of the piezo speaker to the digital pin 8 of the Arduino and the negative pin to the GND. I followed the proper circuit connection or setup based on a given diagram to secure or ensure the correct connections before proceeding to the coding part. And now here it goes. After completing the circuit, I opened the Arduino IDE and inserted the code that has been provided already in the lab manual. As I enter, it sends signals to the piezo speaker to produce sounds and tones. I then tested the code through simulation to observe how different frequencies affect the sound output. During the process, I checked constantly and adjusted both the circuit and the code so that it would work properly. Through this, it helped me to better understand what is the importance of piezo speaker in basic electronics.